Hi everyone. Today I came here to explain the lesson kinematics 1D motion. First, what is motion? What is motion and its parameters? Motion, the definition of motion is an object is said to be in motion if it changes the position with the passage of time. If an object is changing its position with the variant of time, then it is said to be in motion. Otherwise, if the object is not changing its position with time, then it is said to be in rest. There are five basic and necessary parameters to study motion. Motion. There are five basic parameters to study motion. First one is distance. Second is displacement. Third is speed. Fourth one is velocity. And the final one, fifth one is acceleration. See, now first we'll discuss about distance and displacement. The basic thing we should remember is the distance is always greater than displacement, greater than or equal to displacement. Distance is the actual distance. Distance is the actual length of the path described by the particle. Means if a particle is started from here A and moving in such a path to B, then this the total length of the path covered is called distance. It is a scalar quantity. It does not depend on direction, and its unit is meter. So its direct dimensional formula of distance is m power 0, L power 1, T power 0. See, now displacement. Displacement is the minimum length between the initial and final positions. See, here the particle is going from A to B in this path. This total length of the path is distance, but the shortest line joining A and B is this thing. Here, this straight line is the displacement. The displacement is the minimum distance between initial and final position of particle. That is the shortest distance between the initial and final points. It is a vector quantity. It depends on direction. See, from A to B, the displacement is in this direction. It is a vector quantity. Displacement is a vector quantity. The dimensions are same as distance, that is meter, and dimensional formula is therefore same as m power 0, L power 1, T power 0. The basic difference between distance and displacement. Distance is the total path of the covered by a body. Displacement is shortest distance between initial and final position. And second thing, distance is a scalar quantity. Displacement is a vector quantity. And the special case, see this case, for a closed path, the distance traveled means the particle is starting from here and going in a closed path and returning to the same point. Here we see that distance is non-zero. This is body. The distance is non-zero because the distance is this thing, this length. But the displacement is zero because the initial and final points are zero. So that we can say for a closed path, the distance traveled is non-zero. But for a closed path, the displacement is 0. And now let us go with a small problem. First, a farmer. Consider a farmer. A farmer has to go 500 meters north and 400 meters east and 200 meters south. First, find the distance traveled by. Second question is find displacement of farmer. See, first let us denote the directions: north, east, south, and west. We know, see, let us consider this is the initial point A. The farmer goes 500 meters north, 500 meters, and then 400 meters east, 400 meters, and 200 meters south. This is 200 meters. This is the final point B. The total distance, first question. The total distance covered is 500, means the distance means the length of the path. It is 500 plus 400 plus 200. This will be equal to 1100 meters. So the first question answer is 1100 meters. See the second question. This is based on the logic. Means see, this is the shortest distance between A and B, the straight line joining A and B. Now, if we let us draw this again. Draw this trapezium here. This is 500, 400, and 200. We need to find this distance, AB distance. So if we draw a horizontal line here, parallel to this thing, this is 200, so this will be 200. The remaining portion in 500 is 500 minus 200, this is 300, and this will be 400 because these two are parallel. And now we see that this is a right angle triangle in which one side is 400 and other side is 300. By Pythagoras theorem, we can say that the length of the hypotenuse is root 300 square plus 400 square, which is equal to 500. So the displacement is 500 meters. So this is an example for distance and displacement. Let us move forward. Distance and displacement of a particle. Now let us see the distance and displacement of the particle when it changes its direction. When it changes its direction. See, if a particle is starting here, it is going vertically upward and change its direction and returning down. See, when the particle is moving, the distance is always increasing. Means the distance will always increase or it will not increase, but it will never decrease. See, if it is going like this, the distance always increases but never decreases. But see displacement, the particle is going upward. Here's up to here, the displacement increased, but when it is returning back, this is the displacement for this point, this is displacement for this point, this is displacement for this point. The displacement is decreasing. See, when the particle changes its direction, the displacement changes, but the distance always increases. Distance and displacements of particle when it changes direction of motion. We all know that as I said, displacement is a vector quantity. That is denote the total displacement by S bar. The total displacement, uh, this can be applied for n number of changes in direction. The net displacement S net is a vector sum of particles. Means see, I will draw a diagram here. The particle started here. The first displacement is here. Here it's going like, means see, this particle is going in this way. Up to here the displacement, consider this as S1 bar. From here this point to this point, consider it S2 bar. This to this, consider as S3 bar, so on. The net displacement will be, see, the net displacement will be from initial point A to final point B. Here to here, the net displacement is this. As displacement is a vector quantity, I'll write S net equal to S1 bar plus S2 bar plus S3 bar plus S4 bar, so on until Sn bar, means until the last displacement, as there are n number of displacements. Let us discuss the distance traveling the same case. See, here it is starting, it is going here, until here the distance and displacement is same. But when it is returning back up to here, the distance is increased, but the displacement decreased. This vector product cannot be applied to distance. Now let us see a sum on vectors. Means, see, a particle from origin to 10, 0 coordinate, and then comes back to comes back 2 meters towards origin. Find displacement of particle. See, let us draw Cartesian axis first. This is x-axis, this is y-axis. The particle is starting from origin, initial point, and going to 10, 0, 10, 0, and it is moving back to the origin by 2 meters, means 10 minus 2 at 8, 0. The net displacement will, this is the final point, the net displacement will be this in the direction of x-axis. So S net, see, let us apply this vector formula. S net equal to initially 10 I cap and moved back by 2 meters minus 2 I cap. S net will be 8 I cap meters. Okay, understand? And now we'll discuss speed and velocity. Speed. Speed is distance by time. Distance per unit time. Change in distance per unit time. But velocity is displacement by time. The examples of speed and velocity. Again we see this. Speed is scalar and its units is meter per time is second, meter per second. So its dimensional formula becomes m power 0, l power 1, t power minus 1. And velocity is vector quantity. It is has same thing, meter per second, same dimensional formula, m power 0, l power 1, t power minus 1. In speed we have two types of speeds. One is average speed. Average speed. The average speed is defined as total distance traveled, total distance traveled per unit time, per total distance traveled in total time divided by total time. This is the average speed. And instantaneous speed. Instantaneous speed. Instantaneous speed, in this is the thing which we means if particle is moving in its motion, if particle is in motion at a particular point, at a particular instant, if we calculate the speed, that is the instantaneous speed of the particle. See, we'll define it as v instantaneous speed equal to dx by dt. Means if it is going in this path, this is the dx, small distance. If dt is the time taken to cover this distance, This is v instantaneous dx by dt. Same as in velocity, we have average velocity. Average velocity is defined as total displacement by total time. See, it is very easy to understand, but it depends on how you intake your, how do you intake these topics, how you remember, how you understand. It depends on these things. It is easy to understand. Hmm. Let us go with an example. A particle goes from A to B, point A to B on a semicircle of radius 1 meter in 1 second. First, find average speed. Second thing, find magnitude of average velocity. See, I'm not asking the direction, I'm just asking the magnitude of velocity. See, let us draw a semicircle. This is point A, this is point B. The average speed is total distance. Total distance is this, means as the radius is 1, the length of the this semicircular arc is pi r square 2 pi r into theta is 180 by total is 360 is equals to pi meters. Average speed is defined as, we all know that average speed is total distance, means pi meters by time taken 1 second equal to pi meter per second. This answer is pi meter per second. But average velocity, average velocity is total displacement. What is the displacement? Initial point, final point. Distance between initial and final point 2 meters. 2 by total time taken 1 second equal to 2 meter per second. The average velocity, magnitude of average velocity is 2 meter per second. If he asks the direction A to B, this direction, here the I and J are not denoted, so he just asked the magnitude. See, I'm saying and I'm asking a question. See, can D, I'm here denoting speed with V. V is speed and V bar is velocity. Can speed remain constant? Speed remain constant. That is dv by dt equal to 0 in circular motion, or dv bar by dt equal to 0 in circular motion. Say here dv by dt equal to 0. This is correct, but this is not correct. Why? See, in a circular motion, uniform circular motion, in a uniform circular motion, the particle is covering same distance in same time. So the speed remains constant, means uh, total displacement by total time remains constant. Remains constant. But see, in circular motion, at every point, the particle changes its direction. So the velocity not remains constant because it is a vector quantity. It depends on direction, not only on magnitude but also on direction. Now let us go to another question. A particle travels half the speed, half the distance with a velocity v naught. The remaining half traveled v1 for half the time and with v2 for the other half of time. Find the average velocity. See, this question seems to be very complicated, but if it is very easy if we imagine it. See, I'm dividing the, see, let us, this is the total path. See, he said first half is covered with velocity v naught, and in second half, it means in first half time, in first, let us consider this is covered in t1 time, and this total is covered in t2 time. The first half t2 by 2 is covered with v1, and second half t2 by 2 is covered with v2 velocity. We all know that average velocity is equals to total displacement by total time. Let this total displacement is s. This will be s by 2 and this will be s by 2. Total displacement is s and total time is t1 plus t2. t1 plus t2. We average equal to s by, see, this t1 will be, we all know that displacement equal to velocity into time. See here, s by 2 equal to v naught into t1. So t1 will be s by 2 v naught. I'm writing it in place of t1 plus, see, this distance is equal to total, again second half s2 equal to v1 into t2 by 2 plus v2 into t2 by 2. So here, see, t2 is equals to, cancel these twos, s by v1 plus v2. I'm writing it in place of t2, s by v1 plus v2. Cancel the s, the v average will be equal to 1 by 1 plus 2 v naught plus 1 by v1 plus v2. By simplifying it, we will get 2 v naught into v1 plus v2 by v1 plus v2 plus 2 v naught. See, it became very easy. It depends on our understanding. Now, let us come to the final parameter, acceleration. Acceleration is defined as change in velocity per unit time. It is a vector quantity, depends on both magnitude and direction. It will, acceleration a bar is equals to v bar by t. See, its units will be meter per second square. So dimensional formula comes m power 0, l power 1, t power minus 2. See, now I'm telling the difference, dv bar by dt. See, this and this both are different. See, this is magnitude of velocity. Magnitude of velocity is speed. So not every time, but some, when the motion is straight line, it becomes speed. It represents the rate of change of speed. But this represent the magnitude of acceleration, because in mod cancels the direction, but the magnitude, mod means the magnitude, this is magnitude of acceleration. Okay guys, that's all for today.